All right, you guys, we are almost done with this chapter 6 talking about quadratic equations. And now more specifically, we're going to talk about how to graph these things. What do they look like? What do these graphs tell us? And all the information that we can get from them. So when we graph, we said that there's a standard form that we write our quadratic equations in. We call that ax squared plus bx plus c. And now we've been saying equal to 0 so that we can solve them. When we first started, we were talking just about how to write polynomials in standard form. But now if we want to actually graph something, we'll want to say that this is y equals that ax squared plus bx plus c. And so with that standard form, we're able to create this graph. And with that graph of these quadratic equations, it creates that U shape. So we'll have a downwards or an upwards shape. Now, a couple weeks ago, we looked at a Desmos activity where you played Mario, and it was all about these quadratic equations. And with those quadratic equations, you were able to see, where does Mario take off from? Where does he land? Where do I want him to jump from? And where do I want him to land onto? Well, with all of those shapes, we call all of these U curves parabolas. So you might want to say that to yourself while you're at home watching this. Parabola, parabola. That's how we say these graphs that are U-shapes for our quadratic equations. So quadratic equation creates a parabola. And so there's different types of parabolas. They all look a little bit different. For this first one here, we want to use our graphing calculator for these examples and just sketch. So you can use the app that you have on your Chromebook. I just have mine here on my phone, and we can show you how to get that as well when you're in person next. But in order to use the graph of your calculator, you first need to go to where you would type in the equation for these graphs. To get there, you're going to push y equals. From here, you're going to type in the equation just as you see it after the y. So you don't need the y. Your calculator already says y equals right here. So we'll have x. To get x, you'll push alpha. So now you can get the alphabet in, and see how there's this x right here. You can push that to get the x. The other way that you can do it is there's actually this x button right here, the variables button. That'll put in the variable that you need. So we have x squared plus 2x minus 5. Now, these graphs might look a little crazy, so we might have to do some fixing with your graphs to first get this set up, but we can take a look at that here in a minute. Let's go to our graph by pushing the most far top right button here, graph. Thankfully, my window is already set. Your window might not be. So let's take a look. See how this button says window right here? That's going to be the button we use to see where our graph is actually going. So if you push that button and you don't see the same numbers that I have of negative 10, 10, 1, negative 10, 10, 1, 1, you'll want to use the arrow key to go down to wherever you need to fix that, and make sure that when you type in the negative, you use the negative button right here down by the enter. All right, you should have taken some time to fix that up. So let's go back to our graph. So now your graph should look just like mine. And we want to try and sketch what this graph looks like. So I see that there's a bottom piece here. It comes up through over this side, and then kind of the same shape over here. So then I'll create my parabola, create that U shape from my center point, and just go up through those sides. Don't have to be exact with this. It's just more of a sketch. We're not necessarily graphing it right now. So that was our first equation. To answer these questions here, let's take a look at some of the differences of what this equation has and what it looks like when we graph it. So for your calculator that you have on your Chromebook, you'll be able to actually change the color of your graphs. However, mine is not going to change color. I'm going to just graph these together on one thing. So we'll still be able to see what it all looks like. So we got negative x squared plus 3x plus 7. So I've got my two equations here. Again, yours will show up as different colors. However, because mine is not a color calculator, it will just be black and white. And so we said that first graph here was this x squared plus 2x minus 5, whereas this graph makes the other shape. It's almost the exact opposite. It starts up over here, comes through over here, has another point over here, and comes through the y-axis about there. So that one maybe needs to be over a little more, but that's okay. So we'll come through, connect our dots, and get this downwards U shape. So we have these two different shapes that our graph has made. Let's see if we can't figure out some of the differences between these two. So the first thing is that if A is this, then the parabola opens this direction and creates a smile. So which of these graphs creates a smile, and what's the difference between the two and what they look like? For our first equation that we had here, you would say that this is the smile. Our arrows both go up, so it creates that smile. And notice that there's a couple of differences. One of them is that this x squared is just x squared. This one over here is a negative x squared. The other difference is this -5 and a +7, and the numbers are different, but the numbers themselves don't change the graph. It's more so about the signs of the graph that's going to change the direction it goes. Hopefully you all remember that the number that's added on at the end here, or subtracted in this case, those are actually our y-intercept. Meaning that that is the number that our graph crosses over the y-axis, which is why if this says -5, we cross through on the negative side of the y-axis. And if it's +7 here, we cross through on the positive side of our graph. So we know the y-intercept can't be the difference. We said the numbers don't make much of a difference. So the only thing that's different is that this one is negative and this one is positive. So if A is a positive, that's the number in front of our x squared, then the parabola opens up. Our arrows both go up, and it creates a smile. So we would say the exact opposite. If A is a negative, like the second equation here, then the parabola opens down and creates a frown. So you can see that this would be the frowny face over here. So positive is smile, negative is frown. So a couple of other things that we want to take a look at for these graphs. There's this thing called the axis of symmetry, and this is going to be something that you don't necessarily see on the graph, but we know is there. The axis of symmetry is an imaginary line that creates our parabola into two equal sides. So notice here on our phone calculator, if I were to just get rid of one of these, there's almost an exact middle line here that comes through and creates two equal pieces of this parabola. So with that, that is what our axis of symmetry is. It's the vertical line that divides the parabola into two equal parts. And there's a formula to find this, so we don't have to just guess and figure out what it is. Our formula is x equals -b over 2a. So with our axis of symmetry, we'll always see these as an equation. So as an example here, we could have something that says x equals -2. We could have something that says x equals +10. Whatever it might be, it's always x equals a number. Because remember that it's a line. It's a vertical line that divides the parabola into two equal parts. So we have our equal parts in terms of the graph here that we have, imaginary up and down, right through this middle point that I've labeled as the vertex. We call that the vertex because the vertex is defined as the turning point of the parabola. And so since we call that the turning point, it's also called either the highest or lowest point. And if it's either of those actually get the special name. So when the vertex is the lowest point in our equation here, when A is positive, so A positive, This is called the minimum because it's the lowest point. It's as low as our graph will go, so that is the minimum most point we can have. But if A is negative, that's going to be the highest point. So we would call that, like this graph here, the maximum. So our vertex is a coordinate point, meaning that if it's a point, we'll have an X and a Y. Now there's an easy way to find both of these without having to do any sort of graphing or anything like that. We can use our formula for the axis of symmetry to get us an X. Because notice in our graphs that the axis of symmetry goes right through that point that our vertex is at. So with that, we know that the X part of our vertex comes from the axis of symmetry, and if I have one part of my equation, I can find the other. So let's take a look at what I'm trying to say. Let's do an example here. We'll do this first one together. And so we've got y equals x squared plus 8x plus 15. And since I'm going to use this formula for the axis of symmetry, I would want to figure out what A, B, and C are for my problem. We've practiced this before with the quadratic formula. A is whatever's with x squared. In this case, it's 1 because there is no number there. B is whatever's with single x, which is 8. And C is the number or the constant, which is 15. So for my axis of symmetry formula, I actually only need negative b over 2a, so I don't really even need the c. So let's fill that in. Negative of b would make that negative 8, and 2 times a, or 2 times 1. So on the top, I'll have negative 8 still. On the bottom, 2 times 1 is 2, and negative 8 divided by 2 would give me negative 4. Since our axis of symmetry is an equation, we would say x equals negative 4. Now, with our vertex, I said that there's a quick way that we can find this as well. We can take and actually type this into our equation, plug this negative 4 in for the x's that we have. So our equation was x squared plus 8x plus 15. All we have to do is substitute negative 4 in, and don't forget parentheses. Every time you substitute something in, you'll want to use parentheses, especially since this is a negative number. It'll just make life easier. So let's type that into our calculator instead of trying to do that ourselves and see what we get. So in my calculator here, I would want to type in our equation just as we have it, parentheses and all, except for that y equals part, just the numbers. So I'll do parentheses, negative being the button down here by enter, 4 squared plus 8 parentheses negative 4 parenthesis plus 15. So once you've got that all typed in, double check, make sure that you use the negative, not the minus, and that you have your parentheses around the things that you should have it around. We'll hit enter, and we get y equals negative 1. Now again, the vertex is a point. And since it's a point, we need to write it as x comma y in parentheses. So we said x was negative 4 and y we found to be negative 1. So now we want to sketch this. When we sketch this, we'll have our x-axis and our y-axis. And it doesn't have to be perfect, but we'll get our calculators out here again. We'll go back to our y equals. If you still have your other equations in there, use your arrow keys to delete those old equations. And we'll type in our new equation. X squared plus 8x plus 15. And so we go to our graph, and you'll see that it's way over here. Our vertex is down here-ish, and it comes up this way. Again, this is just a sketch. It doesn't have to be perfect. But if you wanted to draw in your axis of symmetry and say that this is x equals negative 4, your vertex is the point negative 4, negative 1, things like that. Now, there's more information we can get from these graphs, but we want to practice first just how we get some of the parts of this graph. So on the back here, there are 8 other examples, 2 through 9, that you can do to find axis of symmetry and vertex and practice sketching it. So we'll do 2 of those examples for today. So do 2 of these examples and then go and do the rest of this video here. All right, so our next page for day 6 is talking more specifically about how to actually graph these equations. So there's 4 steps, and we already know how to do 2 of these based off of the first half of this video, finding the axis of symmetry and finding the vertex. So the first thing that we'll want to do is find the axis of symmetry for these problems. So we'll skip number 1. We'll take a look at that another time. But let's jump and do number 2. So we're going to do example number 2 here. So with example 2, we want to find the axis of symmetry. Remember that the axis of symmetry formula, x equals negative b over 2a. We find the vertex by plugging in the axis of symmetry and then from there, we'll discuss those new parts. So our axis of symmetry, I need to find A, B, and C. Well, A is whatever's in front of x squared, which is 1. B is whatever's with x, which is 2. And C is the constant, the number by itself, which is negative 1. So I'll plug those into my axis of symmetry formula. So I'll have negative B, which is negative 2. Over 2 times A, which is 1, which would give me negative 2 over 2, which is negative 1. So my axis of symmetry, I would say, is x equals negative 1. Now, again, to find our vertex, we're just going to plug in negative 1 for the x's in my equation here. So we'll have y equals negative 1 squared, don't forget your parentheses, plus 2 times negative 1 minus 1. So in our calculator, we'll type that in. I'll put it up here. So we have parenthesis negative 1 squared plus 2 parentheses negative 1 minus 1. And that would give me negative 2. So y is negative 2 when x is negative 1. Remember that the vertex is a point, so we'll have a point at negative 1, negative 2. X comes first. So with these points, we'll want to fill that in to our table. Step 3 here says that we want to put the vertex in the middle row of the table and then fill in the table for the rest of the values. So we'll start off, negative 1 will go here in the middle, negative 1, negative 2. Now when you use a table, we'll want to fill in the other spots. And we'll have negative 1, 1 above that would be 0, and 1 more than 0 is 1. 1 less than negative 1 is negative 2. 1 less than that would be negative 3. So you're just going to go up 1 and up 2, up, down 1 and down 2 to get those other points. And this is kind of the easy part. So in your calculator, you might be able to go back and use the arrow keys to type in what's up there, or you might just have to retype it in. Either way, all we're doing is like we did for the last problem where we typed in negative 1 to get our vertex, but now I'm going to type in the other numbers. And something magical will happen here. We're going to have parentheses. I'm just going to do 0 first. 0 squared plus 2 times 0 minus 1. So we get negative 1 for y. I'm going to do the same thing, but I want to see what happens when I get negative 2. So when I plug in negative 2 plus 2 times negative 2 minus 1. Oop. Let's see, what did I do? Oh, I accidentally bumped those parentheses, didn't I? So let's try that again. Negative 2 squared plus 2 times negative 2 minus 1. I get negative 1. Well, maybe a pattern, maybe not. Let's try and do 1 and -3 and see what we get. So if I do the same thing, when I type in 1 squared plus 2 times 1 minus 1, I get 2. I want to try the same thing and see what happens when I plug in 3, or -3. So -3 squared plus 2 times -3 minus 1. I also got 2. So I'll let you in on a trick. This is actually the pattern, is that once you have your vertex, every point, however far up from that vertex you go, it's the same distance as when you go down that many. So from -1, -2, 0 is 1 to the right, and -2 is 1 to the left. So at 0, we had -1, and at -2, we had -1. And at 1, we had 2, and at -3, we also had 2. Remember that because these are parabolas, these will look the exact same on the left and right. They are a mirror image of each other, and that the halfway point down the middle here, this line right here, at -2, where our axis of symmetry is, that is the line that says this left side of this and this right side of this are going to be the exact same. Now, the other thing that we want to talk about is domain and range. So the domain is actually the same thing for all of these. Your domain are your x values. It's everything that your graph can reach in terms of on the x-axis. So if we think about the fact that this is going up and to the right and up and to the left, and it never stops going in either direction, your domain is always going to be -infinity to +infinity. Your range, very similar. However, we're thinking about y values now. Y values are how far up and down does my graph go. So there'll always be one direction it never stops going. In this case, my graph never stops going up. That means that infinity is as far up as it goes. But if I think about how far down it went, it stops here at our vertex of -1, -2. The lowest it gets is here at -2. So our range goes from -2 up through infinity. So that domain and range piece might be tricky for you. If you need more help with it, I can certainly help you. But let's do 2 more examples. We've got a few different problems that you could do here. So you've got 4 through 11 for examples that you could do. So let's just do 2 of these. So we'll do 2 graphing ones, and you should have done 2 on the first page here from that axis of symmetry and vertex and sketching the graph. So pick 2, do 2, and I will see you in a few.